All right, so we have our data definitions here, right? And we want to take these, we want to construct these from parsing, right? And this is really as simple as starting to just write the different parts that parse these things, right? We can also make types for things that only exist for the parsing process. So what I mean by this, for example, right? Let's look at the initial bits here, right? Here, we could say, okay, parsing a clear value, clear assignment, could be just the word clear, and then, you know, some amount of white space equals a Boolean, right? We could do this. We could also say that we could have an assignment, right, which is a struct which has a, for example, key and a value like this, where a value could actually be value like this, and value could be a union between, sure, which ones do we need to support? We need to support strings, string, and bool, for example, right? And here we could very easily just add int, for example. Right, and this would be a valid way to do it as well, right? Parsing an assignment. This means we can also trivially at some point add other assignments, right? However, what we're going to be doing is mostly, honestly, solve just the problem, right? Because this is great. This is great to kind of end up with if that's what you're doing. You have a clear use case and so on. But I will argue here, this is in some ways future-proofing. Just don't do it. Future-proofing is not a good sign necessarily. A lot of programmers think, oh, well, you know, I can predict what's going to be showing up and so on. And they are much, much worse at it than they believe, most of them. They're not equipped to tell the future at all. And playing Oracle like this with your code doesn't necessarily serve a purpose. I can tell you in the years that this file has existed, since 2019, actually it might be longer than that, this kind of thing has literally never changed. So let's not assume that it will, right? We're just going to say, nah, let's not do that for now, right? Instead, what we're going to say is actually parse clear, for example. And here we're going to take a tokenizer. We might call that a T, I'm not sure. Tokenization tokenizer. We're going to take a pointer to that, actually. This is, of course, a proc. And this is going to return a clear value or possibly some kind of error. Let's say clear value, bool. Let's say clear bool, and possibly an error. Right, and what we could do here is we could just say tokenization expectation error. Let's do that for now, and we'll see what we want to do later, to be honest, right? Let's return here. So here we're taking this tokenizer, we are returning clear or error and so on. And here we could just say, okay, we could just say parse background and set that up already, right? Now we have stubs for these two, right? So how would we go about actually doing this, right? Well, we would ask the tokenizer for some token and say, I expect this to be something, right? Or we could do that at the very least. So let's try that, right? So let's see here, tokenization, tokenizer, expect. And here we want to say probably expect exact, actually, because this allows us to make a an expectation very deliberately. I'm going to say lower symbol here, like this, and a lower symbol has a value inside of it, right? And this is what we're going to be doing. And here we can actually say this returns a source token, or optionally also an expectation error, right? So let's say source token is equal to this, or return, like this, right? Now we have the source token. Now we can, we know what the source token should be, to be clear, no pun intended. So we can actually kind of ignore that for now, like this. We can say, no, you need to read that clear value. And here we can also say tokenization, tokenizer skip any of, like this. Skip string we could do. No, skip any of is going to work better because we're going to allow white space and so on. This takes a tokenizer. Everything takes a tokenizer in reality. And here we have a, let's see, token like this, if I remember correctly. And here we want to skip certain tokens, right? Tokenization space, like this, and tokenization equals. Oh, we don't have. Oh, I think the tokenizer doesn't have equals. Let's see. No, I suspect it doesn't. Let's just say equals there. Let's see here, underscore equals. Let's see here, switch. Here is where we read these. That returns an equals. There we go. So now we're skipping any amount of spaces and equals. This will also, by the way, allow for arbitrary amounts of equals there, which I'm going to allow because there's just no point in being, there's no win here. If we said, for example, oh, this should be illegal. No. Remember, this is a very small thing. It doesn't, there's no win here in disallowing this at all. Right? So let's just not. There's no point to it. We could just do skip spaces and then assume an equals, or rather expect an equals, right? And then we could, you know, move forward like that, right? In saying this, let's just do this tokenization, tokenizer, expect. Here we can use a normal expect. Like this, or return. Let's see here. And then we could skip any amount of white space again, like this. Actually, let's condense those a little bit. And now we should expect some kind of Boolean value, right? So here we can do let's say T is tokenization, tokenizer, expect tokenizer, tokenization Boolean, like this, or return. Yeah, that should all be fine. And here we can essentially say return t dot token No, hang on. Ah, no, we can cast this, of course. Clear token is equal to t tokenization boolean dot value. And here we can say clear is equal to this, return clear. Or we could just say this. And of course nil needs to be here, we don't have an error. Ah, t dot token, of course. So a token here is actually, this returns a source token. And a source token is a token and a location. So now we're basically saying, because this is expecting, right? And this will only succeed if this was in fact a Boolean value. Booleans have values inside of them. And so this cast is safe down here. So that's parsing clear. Now we might have a test for this. Let's just say test private package like this. And here we want to import testing. Yeah, that should be fine. Test parse clear proc t is a testing t. We make a tokenizer. Tokenization tokenizer create. And the source here is going to be, for example, clear true. Testing expect value is what we can use here. Clear should be true, error should be nil. I always do error checking first. This is a pointer to a tokenizer, of course. And here we can't use expect value. We have to do t just expect. This is nil. We add FMT for formatting. And now let's see if we can, let's add this to our task file immediately. Test parser, blah, blah, blah. Okay, so we already have something here. Task th, let's see. Right, mkdir bin. Now that works. There you go. Let's see here if we can just sort of add some stuff here, because I suspect I haven't done this. The test data I also want added, of course, and in here we actually want to say pretty immediately there's a git ignore file where we add bin. Right, that's one step in our entire process, right? We're working on the parser here. We're making it piece by piece. Let's say clear false. This should be very simple, straightforward. Let's have a, yeah, I mean, this is gonna work as well. I would much rather maybe say here, this should not work. And the error we should be getting is an expectation error. Let's see if we can nail that actually down, like completely, right? This should be equal to tokenization expect token. I think. We can't do equals here. I mean, I guess we could, in fact. Let's do this. Expected token is the value. This is going to be zero now by default. So and here, right? Okay. We could just make a bigger structure out of this and just say switch e in If it's nil, yeah, we want to just fail this entirely, right? So that would be, for example, panic. Let's say empty panic F. Like this, and here we have unhandled switch cases, of course. Those don't show up like this, so we actually have to run them like this. We can see we have these here. And here we could actually collapse some of these into like this. And this is the actual one we're looking for. Let's see here. Let's see here. Sure, this is basically what we want here. I'm not getting any autocomplete here though. Let's save this. Is it because I don't have anything here? By the way, in these particular contexts, you can actually say using here, and for this namespace, we could basically use the entire tokenization namespace. I don't really do this very often because I don't think it necessarily is that valuable. I don't mind having a little bit more text in places, to be completely honest. And here, right, okay. Actual right, so actual dot can I say here we can just do expect, by the way. Actual dot token, maybe. What is an actual actually? Yeah, it's just a token, okay. What is the type of this actually? Oh, right. Hang on. Dot yeah. Let's say that actually. Here we could actually just say token, to be honest, right? Yeah, let's just do that. I think that's simpler. We don't need to complicate things. Tokenization dot, let's see, equals. Right, and yeah, let's just try this. Let's just do this, and here we can just say expected error for missing equals token, and here we can just say this. Let's see here. Did not fail with expected token, expected equals actual Boolean value. Oh, expect. Yeah, this is what I need to be saying, I guess. There you go. Let's not go too deep into these errors, to be honest. I think maybe this was possibly a waste of time, to be honest. Anyway, that's our parse clear, right? Writing some tests for it and so on. I don't mind having, you know, writing tests for things, generally speaking. Especially when it comes to a parser, because it's such a testable problem, right? There are problems that are simply not as testable, and you just end up wasting time testing them. You're basically testing your own test code at some point with some of these, right? And that's fucking pointless. But here we're doing something completely different, right? So here, let's see here. Tokenizer expect exact lower symbol background, yes. Skip any white spaces and then take an equals. Here, get a lower symbol. Let's see what we have in that. I don't remember. We actually want a string, if I remember correctly. Though, do we? Or do we just want this? I don't know. There's only dark and light in our system. So let's actually say this. I think that's actually a good idea. So we're reading a dark symbol, or a lower symbol, rather. Here, default. This is the only case, really only case. But I don't know that we need this necessarily. We do need a partial switch, I think. Let's remove the default case entirely. And here, return. This is supposed to be a background. Let's say background none here. None. That's a poor way of doing it, I think, but let's say we want if we weren't able to read a lower symbol here at all, we were just gonna have an error, right? If this value is anything other than dark or light, we should probably just have an error. right? So let's say we want some kind of expectation error here. Right, expectation error, expected token. We could do expected one of. Let's see what that actually means, right? Expected, actual, and so on. And this should be t token. And is there more? Tokenization. That's in fact why it's called this. Expected actual location, right? We have the location actually, so we can just say t location equals t dot location, I think. Yeah, that's all fine. Here we want obviously a few things. Tokenization lower symbol, value dark, value light, like this. And that's if we don't have any values here, right? Now, I'm not super happy about the Xenum having this none, because it's sort of just bleh, right? But let's leave it. Let's not hyper focus on these things, right? I do think it's mostly unproductive to go too deep into things. We should be able to replicate a few of these tests, to be honest. Let's see here. Tokenizer create, background equals dark, that's all fine. This is gonna succeed. Parse background with the tokenizer. We then have unexpected error, sure, background light, background dark here, background light. These are success tests. Background none should definitely fail. Let's see what actually happens here. 2259 in format. So what is happening here? What are we doing? Here we're testing the equals, and here we're testing kind of nothing. Right. Let's comment some stuff out to see where we're hitting this format error, because this is not our code really. We're going through our code, of course, but we're ending up with an error in format, and that's where stuff is getting really interesting, right? Here, let's see that we can parse the success cases, and we can, right? So it's clearly here something's going on. Parse background. We are going in here, and format obviously in some ways is suggesting here that one of these panics might be the thing, right? And here we actually want one of for sure. So that's something we have to, right? Because it is one of that we are obviously. We're basically saying this, right? And we have to do slice compare here, very likely. We can't just say this, probably, we'll see. tokenizer expect token really is handled like the others. Expected token like this. Can I compare? Yes, that makes sense. Slices compare. Let's see here. Slice. Oh, it's slice, of course. Let's see here. Comp. Right. This is not going to work, maybe. Well, we'll see. He expected comma, the rest. And here this is going to complain that we don't have this, right? We can't compare these, in fact. And that makes sense. So slice dot, let's see here if we can find anything. Otherwise, we're just going to make a, let's see here. If len of e expected is not 2, panic f, like this, that's fine. Yeah, expected is a token indeed. We are going to assume they are lower symbol values. This will crash otherwise, it's fine. Invalid type got string. Oh, hang on. Yeah, that's all fine. Let's see here, core slice is not needed, sure. And here we can now see that this is all fine. Dark found, let's see here if we can just sort of, how do we invalidate this, right? Yeah, actually no, let's just not here. This one, let's just leave this for like this. Yeah. Okay, so now we can parse clear equals, we can parse background equals, and so on. So that's these taken care of. And again, we remove the strings here, so we don't really need to, we remove the quotes here because it should be dark or light. That is it, right? And our test now basically says it has to be dark or light, right? And this is something worth testing, to be clear, I think. We do want it to be that. Let's see here, expected error for background to be either dark or light, God knows. Yeah, that's all fine. Let's see. What more should we be doing? We have clear and background. We want to parse some groups now, right? And parsing groups will be as simple as just saying, let's see here. We will start with a few different things, right? Let's see here. Actually, this might be a good place to stop this segment, and I will continue doing this in the next one. So I'll see you in the next one. Ciao for now.